Welcome to TechWise TV on the Cisco Interaction Network. Please remember to submit your technical questions in the field provided at the bottom of the viewing console. You can also email questions, comments and suggestions to techwisetv@cisco.com. Thank you for joining us and enjoy the show.
What is the true potential of your data center? It's a brave new world as Cisco introduces unified computing and the dawn of a new data center.
This is stateless unified computing. Now we're really changing the game.
We'll show you what happens when experts from server, virtualization, and networking realms get to ignore the conventional wisdom and build the perfect data center.
If anybody thinks that this isn't a fundamental change to the way things are done and they see those points that we've been trying to do a good job of drawing out here, rewind, go back, watch it again.
TechWise TV's investigative team has groundbreaking information straight from the developers.
Would you like management with that? Would you like other stuff? Right? What we're doing is saying, you know what, that's not hard. The hard part is actually coordinating it at scale in the network so everything can move around.
And hands-on access is the way we roll. Today we meet the experts and take apart the gear to discover what's driving this architectural transition.
All the state has been sucked out of it, essentially into the network. So it's just kind of bare capacity waiting for you to associate a service profile and turn it into a real server.
Old problems are now solved in ways never thought possible. We'll reconnect the dots as we re-explore the family of Nexus technologies that seem suddenly even smarter than before.
When you look at unified fabric, you look at VNLink, you look at the fabric extender technology, just on the networking side alone.
Wake up, stand up. The dream of a better data center is now reality. Today, everything changes. Today, everything comes together. This is TechWise TV, technology you can use from geeks you can trust. Only on the Cisco Interaction Network. Welcome to TechWise TV. I'm Valerie St. John, along with Cisco Solutions experts Rob Boyd and Jimmy Ray Purser. Hey, guys.
Hey, Valerie, how are you?
Good. Our focus today, the dawn of the new data center. Now, in the past, you guys have maligned the use of the word unified as overused, but this time's different. This is huge, right?
No, it really is different. In fact, one of the things that I think is going to become very important to this show is that we understand that there's a true paradigm shift, if I'm allowed to. I don't think that's a term that's been abused in a long time. But there's very real technology that backs up why unified, if you were to pick any word to try to describe the level of innovation and such that we're going to be talking about here, that is one that describes it very well. And so I think it's important, and there's real technology to back it up.
Just to make sure that I understand this a little bit, let's take it back. Let's talk about the history here. What's been the evolution in the data center? What's changed?
Well, a lot has changed in the sense that if you go back far enough, you look at, we had mainframe days where everything was centrally contained. Then as intelligence got put into the endpoints, we put those in the hands of users. We lost a lot of control, but we gained a lot of things. And we took that same PC model that developed out of that, and we've attempted to bring it back into the data center. But there's been problems from that because we've got a PC model that's really not built to handle the stresses that we're putting data centers under now. And so, you know, a lot of innovation has been attempted to bring that under control, but fundamentally it's been the same thing attempted over and over again, when in reality, perhaps if we could look at it a different way, and that's just something we'll talk about in this moment, but you know, could we do it differently? Right,
and which leads us to this question of business agility, the whole idea that it must respond very quickly to the business challenges,
and
right?
I'm glad you brought that up, because I think business agility is exactly what we're talking about here when you talk about the desired end result. So Jimmy Ray and I, we may get wound up about talking about technology, and we probably could get carried away with talking about technology for technology's sake, but at the end of the day, the reason the IT department exists is to execute on something that the business has said, hey, we need to do something to, you know, take care of the changing market condition. Yeah. The speed in which you can do that, the speed in which the business uses their intelligence, you know, using this loosely, and says we need to deploy these applications to do this, how fast we can actually make that happen is what we might call business agility, and becomes very crucial to being competitive, to be able to differentiate. And in fact, I'm reminded of a story. Yeah. A customer had made a reference to the Golden Gate Bridge and describing how they rolled out applications. They had, I think in this particular situation, it was around 400 locations, you know, which is not an atypical situation, really. And the problem they've got in rolling out technology is they said it's like painting the Golden Gate Bridge. We start at one end, start with one location, and then we go through each location rolling out the new application. we're doing this to respond to a market condition, but it takes 6 to 12 months. You know, as soon as you get that one done, what do? You start over and start painting again, right? Because by that point, it's time for the next thing. Well, how agile is that if it takes that long to roll out an application that the business already decided? In fact,
not very.
What is the reality behind the scenes? Because you've dealt with this before. What happens? I mean, how many different people are really involved when it comes to deploying something new?
Well, you know, it's a real pain in the tail. I mean, the further up the ladder that you go, the bigger your business gets, the more hands you kind of have involved in here. Smaller businesses rolling out applications, that may not seem like a big deal. I go out and buy the apps, I buy the license, I install it on the server, everybody uses it, and have a nice day. The larger, the more data center based type customers and stuff. Typically, if I'm going to even put a new application on, I got to go through some type of change management protocol.
Right.
I got to actually have backout strategies. I got to have plans. I got to have maintenance windows to actually set all this stuff up. I have to have people standing by. You know, it is a humongous task to roll out a new app, even to patch an application. It's huge.
But aren't we talking about different people handling different levels of expertise? I mean, you've got
Absolutely.
server people doing one thing, but then they rely on getting data from a networking person who's got to give them certain pieces of information. Then they've got storage, and you have these different elements, and it becomes kind of this complex orchestra that's got to happen every single time an application comes out, right?
Absolutely. And you got to have NOC people that are watching the stuff, see any ripples in the network happen. Because if I have a small, let's say I've got an international company, and I have a small blip in one data center site, the hysteresis effect of that rippling effect going out all over the world is huge. And once it starts, it is nearly impossible to stop.
So what you're describing here is not just a major logistical problem. This is a major fiscal problem. What's been the solution up to now?
Well, here's the thing. I mean, and this is why I say it requires a paradigm shift, because we describe this, obviously, we're trying to do, I think, let's be straight up about it, as a typical presentation fashion. We need to understand the pain that we're here to solve.
Right.
So that's why we're bringing it up. We just want to make sure everybody understands the area that we're trying to address, because things we're talking about are normal. These are status quo for any operational environment, and it isn't often questioned about how do you actually change things. Because the stuff, back to your question, what has been done to change it, well, if you, I'm going to oversimplify it to a certain extent, but really all we've done in the past as an industry is, well, we've either sped it up or maybe we've overlaid some management on it to try and solve some of these issues. But what happens when you do a lot of that is you simply either speed up or introduce more complexity to the situation. Now, virtualization is probably the most fundamental game changer, if you will, in terms of what it brings to the industry. But virtualization, for the benefits it brings to optimization and better utilization of resources, also introduced a lot of additional complexity or problems that now had to be answered because we didn't even know that the question needed to be asked until we actually did it. And so addressing how virtualization plays into that is still important. We just need to understand how to deal with it. Is
Cisco doing anything to address the challenges here?
Yes, we're a company that makes acquisitions and things like this. But if you peel back that onion a little bit further and you look at the history and where some of these things have come about, you're doing a disservice to us and yourself if you don't realize that in this particular situation, we acquired a company called Nuova in the last, I think this is the last few years. I'm not good at quoting the dates. But essentially, Nuova was a company created by some very smart people at a high level within Cisco that said, we're going to go out and solve some problems that haven't been solved before. And they went out, but they didn't do this alone. They looked at the problems that they wanted to solve in the data center, and they brought in experts from the virtualization side. From founder from VMware, experts from Sun, server experts, virtualization experts, and they got their heads together and gave themselves permission to start over, permission to say, hey, let's ignore legacy for just a moment. Let's look at the problems that are really driving us nuts and say, if we could ignore how all this stuff got to where it is and just start over, what could we do differently? Give themselves permission like that, and innovation comes out of that kind of thing. And so I know I'm leaving a lot of the details out, but I just want the groundwork laid for what we're going to talk about here for this notion of unified computing.
Right, which allows us to expand on that a little bit. Why don't you start by just defining that for us in the scope of this conversation? What are we really talking about here?
So as I mentioned before, I think unified is the best single word to say it. And then the next question becomes, what are you unifying? I know we still laugh at the term. I know.
Still using that unify. Can't get beyond it.
But it makes sense. And when you think, because what we're doing is, from the definition, back to your question, is we're unifying the compute area that's normally handled on servers, and still is really to a certain extent. It's just how we do it. Storage, network, virtualization, these different, somewhat siloed areas now being unified under a certain umbrella. I mean, does that definition work for you, or how would you go about describing it?
You're half close. I would say if you add stateless to that, you're right on target.
Okay, so you consider stateless a silo that gets introduced to the equation or just becomes part of the solution?
Stateless is I mean, stateless is a term that we've used a lot of times in firewalls and security and things of that nature because we need that type of healing aspect when it comes to any application. But stateless is not a term we use too loosely in data center type of products here. And to really get our arms around what this is more than just a unified computing architecture is good, but it doesn't really kind of put your arms around what the product really is. I mean, there's a lot of ways I can say this is unified in that because I'm plugging it into this, or I'm using fiber channel Ethernet, I'm unified that way. This is stateless unified computing. Now we're really changing the game.
Okay, well, let's go ahead and address the elephant in the room because there's been no shortage of press guessing at what Cisco's coming out with. Now, as we talk about it today, the product has not been launched. It's no secret this show is taped in advance, and we're going to get some advanced look at some certain things. But by the time people are watching this show, the product will have launched. Some of these questions will have been answered. But the biggest thing that everyone seems to love to lead with is Cisco's getting in the server business, right? Yeah, Cisco's coming out with a Blade server. Is Cisco in the Blade server business?
No. And you know what? That was something that I thought, too, when I first heard of this. I'm like, what are we doing making a Blade server? I mean, there's no shortage of those out there. You can get those from all kinds of vendors and stuff. And then I found out who was doing it, the data center group. I'm like, I know it's not a Blade server. Those guys are doing it because, I mean, you're talking about the Nexus team who put together some of these products. I'm like, but what are they doing? You know, because it's not, I know knowing them, it's not a Blade server. What really is this
It's obviously messing in that backyard, right?
Yeah, so there's something here that's a little different. And once I started understanding the story, it was, a Blade server doesn't even come close to describing what it is. It's not even the same category.
So how would you describe it architecturally?
Well, you know, what we're really looking at is truthfully an architecture that is built for optimization, or not built for optimization. Of course, it is,
for virtualization.
But for virtualization. Yeah. I get my Asians mixed up, you know. But what we're looking at is how do we optimize? Everybody's going to virtualize in a data center. How do we build an architecture that supports and takes it to the next level with a virtualized type of environment? And this computing platform does that. How do we make it scalable so that I can actually scale this stuff? And most importantly, how do I manage all this stuff? You know, Blade servers, data center stuff, I've got all this crap that I've got to manage individually. I've got all these different little element managers everywhere. And to change the game, I can't be running from manager to manager. I can't buy a whole box of Blade servers and have to buy management servers to go in those Blade servers to manage those servers. It's like a snake eating its tail. It's like,
but that's what we're trying, right? Well, historically.
Well, that's what it's been.
Okay, so hold on. I've got a list of things. We're calling this kind of a setup, a tease, because the idea is we need to find the real technology that backs this stuff up. But I was keeping a list of the stuff that had been jumping out at you that you wanted to make sure we covered.
Yeah, right.
And so I would say this to our audience to say, look to how we prove that these things exist. Keep your checklist. First thing on the checklist: single management platform.
Yes, absolutely. I mean, like I said, that is really critical when it comes to managing a data center today. The downfall of data centers is how do I manage those? How do I extrapolate the information that's in those and actually have some usability in there? How do I go beyond just standard, MIB polling and monitoring and just some basic stuff that's built in with a lot of the proprietary management systems? None of the management systems talk to each other. They're all very closed.
Well, here's the thing. I'm anxious to get to the meat of this stuff, so I'm just going to list it out real quick. We've got the VN-Link technology that we've talked about. Very innovative stuff. We've had a show on that before. We've got the virtual machine policy, the application to look at there in terms of how that's done.
Yep.
The comparing kind of traditional architecture with really what is a new architecture here in this unified computing, centralized and uniform switching model. That changes. The I/O bay reduction, and is the software, and where do we locate the management modules now, and how does that change? All stuff that I think we should be looking at here.
Yeah,
all right, lots of promises made here. I will have to keep my eyes on you and make sure you live up to them. Coming up next. Big promises for hope and change are only meaningful when backed up by real technology. Rob and Jimmy Ray have obviously been given some privileged VIP-like access to the development team. So, gentlemen, your task now is to begin backing these claims. Go.
And that's the truth, right? We need to back them up. And as we look at how do we begin this paradigm shift, how do we truly define what we mean by unified computing? Because I think everyone expects us to be able to tell a networking story, and that's going to come out naturally on its own anytime we're talking about Cisco. But we looked at what different guests, because there's quite a few innovators that have been a part of bringing this solution to the point where it is today. And there's one guest that we talked to that we said we've got to have this guy on the show. So I do want to welcome David Lawler to the show. David, you spent time, as I was going over your bio and we have talked, you had a lot of development expertise at Sun. You've done a lot of very interesting things on the server side throughout the 90s. You were there for quite some time. You obviously left and went to Nova at some point and helped these guys, and you're part of that side that has brought the market to where it is now. And now you've got the, I was going to say unenviable task, but actually it's kind of quite fun, as we've been talking about, saying, hey, there's a new and there's a different way to do things, right? So welcome.
Well, thank you.
Rob and Jimmy Ray are obviously extremely excited about what you and your team have brought to Cisco. What's brought you to this point?
You know, that's a good question. I mean, basically, when I first heard about what we were doing and what we potentially could do at Nova, right, you know, there was the Cisco angle to it and looking at a fabric, and frankly, I'm not a networking person, right? I couldn't set up a network in my life dependent on it. But what they were actually recognizing, and having people from VMware, there, Ed Bugnon, who was founder and CTO, looking at it and actually recognizing where the data center was going with it. A server is not going to be something you install in the data center and 4 years later you go on and install it. The server is going to be this thing that actually is fluid and moving around in the data center. So it's really important to customers, isn't just the server, but it's also the connectivity. Those two things have to be one, right? And that's what we were looking at, is looking at that and the scale that people are actually getting to in the data center or have to get to, right? It's a new model. Today to scale, and you know, to scale a data center, what people are doing today is they say, okay, I need more computers. I need bigger data centers. That's the answer today. That's it.
More and more, right?
More and more and more, right? That's all, right?
That's
you
right.
know, and it's more physical, and it's also more virtual, right? A virtual machine still uses resources. It uses storage. It uses network. Still have to license the software for it. So that's still there, and somebody has to manage all that, and it's all moving around now. It's not like it was just fixed in the data center. It's all starting to move around, and there's more of it. And people are going, you know, okay, we'll get some more, right?
Yeah.
Wrong answer. Right?
Went from server sprawl to virtualization sprawl.
That's exactly right.
It seems like
Yeah.
well, so you've got your list of, I think it's 4 game changers. Might be a few more that come out by the time we get done. But I want you to keep us honest here. So, Jimmy Ray, where do you start? What are the things you say? Hey, make sure you notice this.
Well, you know, I think that one of the things that we need to look at is the fabric itself. I mean, you know, we're talking about data center designs and stuff. We're kind of far beyond the loop data center designs. I mean, everything now is a fabric, and I think in a fabric type of design, our entry point needs to be 10G, and especially you know some of the work going on in the IEEE with 40 gig and 100 gig, we need some scalability to kind of build up to that. But the problem is speed is the enemy in the data center a lot of times, because a lot of times, you know, we're not prepared for all that extra speed. It's like having a great car and then, you know, driving it on a dirt road, like, man, this thing drives like crap, you know, and then driving on a good road, it drives great. Well, you know, you got to consider the road that you're on and how we're transferring all this data back and forth. And look at how data centers are designed today, kind of by accident or kind of by happenstance, if you will. The higher the speed, the more problems that can cause and stuff. I'm kind of wondering, how are some of these problems solved in this current architecture with some of the speed issues, some of the sprawling issues? You know, I mean, because we really got to look at designing this from scratch. And this is what killed me when understanding this product here, is that we did everything different. I mean, we designed it from, you designed it, not me. I went out into a soldering iron or anything. But how did you build this up? I guess start from scratch.
Yeah, from starting from scratch, right? And you know, you cover the you know, just the multifaceted team basically. The guys coming in and looking at it and asking questions. You're like, you look at the other guys and go, "What? You're serious?" Right? You know, and looking at it. Let's talk about the 10 gig. You know, when I'll tell you a secret. You talk to the server guy and they go, "I don't need 10 gig."
Well,
right?
yeah, of course.
I don't need 10 gig. I mean, I need fiber channel, I need Ethernet, but I don't need 10 gig Ethernet. It's just not there, right? Right? And the other thing about it is that 10 gig, you talk to most people and they go, it's 10 times 1 gig, right? Right. That's a lot faster, right? It's not what we did, right? You know, what we've done basically, and you know, working with Cisco, you look at data center Ethernet and evolving Ethernet. Ethernet is a healthy, living protocol. It's evolving over time, basically, and we've evolved it into a lossless, low latency fabric, right? So you can actually get a higher quality of fabric out of it. Right? And that was one of the things, is actually taking it and saying, okay, 10 gig has to evolve into being actually a fabric that can cover multiple things. Right? And so you have the fabric that can do a lot of stuff. We build with that in the standards bodies, basically say, okay, we want one fabric to actually address the issues we've got here. Right? You look at the challenge in the data center, and people have servers with, you know, multiple 1 gig connections coming out of it, right? And they'll have some fiber channels connections coming out of it. Exactly, right? You know, and it's not that people say, they don't need 10 gig, but they need more than 1 gig, right? Okay, so there's a challenge. Right? So looking at it, what you want to do is actually simplify that environment. Right? And say, okay, it's not about some Ethernet connectivity and some fiber channel. It's like you need bandwidth out of that box. Right? And that was a simplification on it. It's like, okay, yeah, you talk to a customer and say, yeah, I need like 8 gig total bandwidth, and you know, with fiber channel and Ethernet and all that stuff together, right? But if you just talk to them about this, okay, it's just one, you know, 10 gig connection, it's like, nah, I'm not there. right? I don't see that, right?
Very true.
So it's evolving that into a unified fabric, right? And in doing that, basically, and this is the acceleration problem you talk about, is you talk to customers and say, and everybody's been trying to go for this stateless computing, right? Great. Nice vision. Sounds good. You know, diskless computers and boot off the net and understand wherever you're coming from. It's a great idea.
VAX VMS 1982.
Oh, exactly. Nothing's new here, right? You know, what they've actually seen is that you know, people focus on making the computer stateless, and then this computer's got 3 Ethernet and 2 fiber channel. This one's got 5 Ethernet and 1 fiber. You know, it's like, okay, guys, you left state here.
Yeah. What's that?
Exactly.
There's no stateless in that.
That's exactly right. So that's what we wanted to do, and we looked at the technologies on the market, right? And some of the technologies on the market were saying, okay, great. You know, some of them have said, okay, you got Ethernet, you got fiber channel. What we're going to do is we're going to give you InfiniBand. We're going to roll everything into that. So you have 2, so the solution is to make it 3. That wasn't what we wanted to do, right? We wanted to simplify this environment. Say, okay.
Go in the wrong direction.
Exactly.
Exactly. Been there, done that.
So we said, okay, what if we can actually, in evolving Ethernet and making it a better thing, make it be able to handle fiber channel. So you get the unified fabric. You get a true wire-once infrastructure, right? Take the state out of the wiring in the data center, reduce the cost of the networking, reduce the cost of adapters, switches, all those components, right? That was the first epiphany, sort of, was like, okay, that's state. We can simplify that, and there's pure cost savings right there, and customers can understand that so long as they trust it. Right? And trust is
there you go. Now,
that's
see, that's it right here, because we're talking to the data center crowd here.
That's right.
Who have been promised a lot of things before in the past, and it hasn't been delivered on, and we can go through technology after technology. So how do we build that trust up here? Because, I mean, that's something I didn't trust. I mean, when we were first talking about this solution, I'm like, yeah.
Yeah, I mean, the way you earn trust basically is, first of all, through your partners, through certifications, right? What's different about the networking world versus the server world is the networking world actually does, because it's defined by definition interoperability, they're very solid and clear standards, right? And the server world, it's like, well, it's either an Intel or an AMD processor. It should run the operating systems, and there you go. That's it, right? So to get that trust on the fabric level, basically, is okay. We can do this. We can drive it to the standards body. But people also say, well, who else? Right? And we came to the market with the, the QLogic, Emulex. We're doing all that, and we've got, the EMCs. All these companies.
Heavy hitters.
Exactly. The heavy hitters going, yeah, this is a fabric.
Well, speaking of that, though, because you bring up the adapters and stuff in there, you've got that on your list as well as some of the innovation that's occurred.
Yeah. Absolutely. That was something that impressed me. If we just came up with the adapter only in this solution. The adapter was incredibly impressive, how it was designed and how everything was brought into the single Cisco ASIC to bring all this connectivity in. Can you give us a little more background on just the adapter? So, I mean, I think we could do a whole show on the adapter. That amazed me.
That one alone, I mean, it's a phenomenal engineering team that did that one. They focused on it. They said, okay, I can cut down on wires, but you know what? A lot of operating systems, they don't do VLAN tagging, for example, in the OS, or optimized virtualization. So what we did is we developed a virtualized adapter. And this adapter basically is following the standards PCI-SIG SRIOV, which is called single root I/O virtualization. What that means is a single PCI Express device, physical device actually, to the operating system, to the PCI Express bus can be up to 128 separate devices. All right, so what that means basically...
On an adapter?
To the operating system, one adapter, yes, but the adapter looks like up to 128, either Ethernet or fiber channel, right?
How did you do that, though?
Good engineering. I mean, it's looking at the problem and trying to optimize and trying to look at the problem overall, right? What we looked at, and this is where we start, and I use the term unified computing. We've been talking about unified fabrics, unified this, and I agree. It gets overused. But what we saw is that configuring the network for all this compute stuff, if I want to optimize it, actually the network's got to go all the way into.
Too much of a hard line between these
exactly
things,
right. Exactly. So where does it need to stop? Right? And one of the things we wanted to do basically is let's optimize the performance of this platform, right? And so if you're looking at optimizing virtualization, one of the biggest challenges you actually have in the roadblocks is I/O, right?
Absolutely, positively.
Exactly. So we wanted to say, the way it works today, all the I/O has to go through the hypervisor. The hypervisor goes, okay, I'll deal with all that, right? What we did basically with this adapter is said, okay, what we can do basically is have the virtual machines communicating directly to the PCI Express bus. Now, you have to do that. You have to work with partners. This gets back to trust, basically. So we did this with VMware, right? All right, so this is something that we're coming out with, right? We've announced it by the time this has been aired, but it's something that's going to be shipping in a couple of months, right? And the technology here basically is that with this single adapter, what I can do basically is coordinating within, and it takes management coordination. We'll get to that later, right? I can actually coordinate virtual machines to communicate directly to the PCI Express bus. I create a PCI Express device, right? And then the hypervisor creates the virtual machine, connects it directly up to the hypervisor, the PCI Express bus. And then what that means basically is that as I have I/O, I use less CPU cycles, increase the actual bandwidth, and a lot lower latency for my I/O.
Whoa.
And so you couldn't have done this kind of innovation within any single company, right? A server company is not going to do that. The networking company by
Yeah, can I
itself
build
is
that
not
from
gonna
the
do
parts bin?
No,
If I got the parts bin now,
This whole solution is not something that comes out of the parts bin. I mean, there's people going to say, well, if you do this, and put a wrapper around it, and I do that, I can do it.
Silk screen a logo.
Exactly. Well, let's look at just the adapter, right? If I take this adapter and up to 128 devices, right, single machine, right? But I've got this, and in the overall unified computing system, I can have up to 320 compute nodes, all right? So multiply it out. Let's say it's thousands. Right. Coordinating virtual interfaces with PCI Express devices with network policies all the way up to the network out. That has to be one unified definitional phase. Right? If you have to coordinate all that, I talked earlier about moving everything around, and there's thousands of objects here. But now, if you want to do it with performance, you want to do it with scale, and then simplify it, that's what we looked at, and identifying and being able to actually map these components out. That's what we can do with the adapter, right? But the adapter fits into the overall model. It's part of the solution.
I guess the thing that kind of gets me too, which is another thing on my list, is that as we're the problem with virtualization is managing all that mess. And so now you're talking about putting 128 of these on an adapter. And I'm thinking, okay, that's cool for the data sheet, but as the SAN guy, how do I manage this stuff? I mean, are we still talking about calling MIBs and running a proprietary type of management solution? Like all the blade systems I see out today, they're closed. I mean, the management is very closed, and it's hard to integrate applications into them and stuff.
Yeah, absolutely. I mean, if you look at blades today, basically, blades are a physical optimization at best, right? They basically took the same parts and said, you know what, to make these smaller, we could sort of share cooling and fans, and that's it.
Yeah, it's
right?
micromineralized.
That's right. And then because they did, they actually threw more management at the problem, right?
Yeah, that's right.
And as we know in computer science, every problem is solved by another layer of indirection. That's what they did.
That is absolutely
okay, so
right.
it doesn't make it more reliable or better. It just solves a tactical problem. We looked at this, and we looked at the platform as a device, a large, scalable, modular device, right, with all of the components being unknown and defined, right? And so as you add in componentry, whether it's the adapter, blades, chassis, fabric extenders, everything, they plug into the system and they become resources for the device. What we have is a cohesive management model in the system that's built on a model of understanding it, and it actually builds up, creates a finite state model of everything that's in the system. So you're actually manipulating a single device, but that's scalable, up to 320 compute nodes, multiple racks, multiple chassis. A chassis, the overhead of an additional chassis for us is zero, right? It's the same management overhead to manage a single chassis of 8 blades as it is 320 blades. It doesn't matter. That's just capacity to us. The computer industry over the last 20 years, you talked about the evolution, but it's always been this optimization for the current cost master, whatever that is, the biggest part of the cost. In the mainframe, it was the computer. Let's cut that down, right? And everything has changed. It's actually gone from where it was mostly capital costs with the computer down to operations. What we're doing basically is looking at it and saying, let's get the operations costs back under control, allow people to actually manipulate it, increase the productivity of the people we have today. At the same time, and this is critical, right? It's not just about, hey, we'll make them do much more faster. That's great. Because you also have to plan on failure. And what I mean by that is that hardware will fail, software will fail, and usually you don't know what failed, to be honest with you, right? And so, the industry term we use is mean time to repair. It's a great term, right? Let me ask Jimmy Ray. Once you found the problem, how fast does it take to fix a problem?
It's relatively quick. I mean, you can bracket it out, you can jump right to it and fix it, solve it, and go.
Especially in our case, everything's hot plugged, so I can pop it out and pop a new one in. Pretty simple to solve, right? Mean time to diagnose is a different world, right? Finding what the problem is.
Yeah, that's a big problem.
That's right. But in the industry, MTTR, mean time to repair, includes diagnostics.
I want to hit one more point.
Wait, stop. Because
you did to me.
Because you're saying that everything's hot plug, and I can't let you get away with that. Where does my application live? I can't pull a server out and put this application on another server. I mean, how am I? Because
if you plot a running blade, it's going to die. There's no doubt about that.
I mean, what about the application lives on it? If I got to replace that,
right?
How can I pull that application and reassign that to another resource?
Okay, and you're absolutely right. What we do basically, as opposed to actually having to manage down to the physical node, right? What we do is we take the model that people have today, right? The model that people have today is you define a certain amount of compute resources, you define the network resources.
That's a silo.
Exactly. Each silo defines their component. We take that and make that a logical model. If the company wants to, for good organizational reasons or whatever, keep having the networking guys do that and the server guys, they can do that logically at this point, right? And then once it's defined, we call call that a service profile. Once that profile is defined, you use that, you apply that to the hardware. Now, to your point, once I've got them, I want to pull a blade out and there's something running on it, I simply say I'll take that service profile, apply it to another blade. From every way you look at that blade, right? From MAC address, worldwide name, BIOS, BIOS.
BIOS?
Yeah, part of the service profile, right? This is a complete system. Right? It's not just an afterthought. As I said, not the part spin. You're like, oh, what we've done is we've consolidated multiple independent management planes into a single system so that you're looking at it and you're managing a single system. Right? Competing systems out there, they're management brands. Right? And I'm not going to pick on any one. I can pick on all of them, frankly. Because they're all the same thing, right? I mean, they're brands, but if you'll have a single screen, and that single screen says, oh, I've got firmware over here, and I've got identity over here, and I've got this. They're all maybe on the same screen. But for identity to work, you've got to make sure that firmware in all the blades is correct. So you better check that first, or I'm just not going to work, right?
Right, that's right.
Right, and then access to the chassis managers, right? The state of the art for chassis today, and not for ours. Ours, we've changed that model. The state of the art for chassis today is not you have 16 blades with a clustered management model inside of it that does three things. Right, it does power management, cooling management, and access control. And by the way, you have to update the firmware on that separately. And maybe you can buy another piece of software that actually does that and coordinates it across all.
Once people get it working too, they're like, don't touch it.
Exactly.
Yeah, that's exactly what
we got everything just right, so we better not mess with it, and thus your agility goes right out the door, right?
Exactly. Yeah. That's exactly right. I mean, the management models today, and the way I like to look at it is almost, it's almost the McDonald's model. They'll sell you a server and go, oh, would you like fries with that? They'll sell you a server and go, would you like management with that? Right? For us, it's built into the system, right? An unusable resource, a resource that you can't manage is a useless resource.
Yeah, that's right.
Right? And so server vendors, basically, if you look at a server, a blade from any of the vendors out there, right, let's say 80% of the value, processors, memory, disk, right, chipset on it.
Off the shelf.
Off the shelf.
Yeah, nothing new there.
That last 20%, well, that's a little bit management glue and then hand holding, right? But then they say, oh, would you like management with that? Would you like other stuff? Right? What we're doing is saying, that's not hard. The hard part is actually coordinating that at scale in the network, and so everything can move around.
So before we close this out, Valerie, I just want to make a point that we only hit 3 of your game changers. We hit the fabric, we hit the adapter, we talked about management. So in the next segment, I want to make sure we bring up, and actually we're going to have you back in segment 4, I want to make sure that we come back to some of the innovation you've done around memory. Because that's a story I don't want to miss.
Oh, yeah.
That is a great story.
We can get around to that.
That's all right. There's a lot of good stuff to talk about.
Thanks, guys. So we're not done with David yet. It's time to open that shiny new toolbox and put it to work. We're taking apart the hardware next. Online, on demand, and on the go, this is TechWiseTV, technology you can use from geeks you can trust. Today we're looking at the dawn of the new data center. Rob and Jimmy Ray twisted some arms, called in a few favors, maybe made a few threats, and as a result we have a first look. And now that we've gotten it all together here, we welcome Brian Schwartz, an engineer with the Unified Computing Center, to help us take it apart.
Thanks.
Hello, Brian.
We got some serious toys on our table here. Why don't we just walk you through them? Let's start with the blade design here. This is, in some respects, it looks to be a pretty standard x86 blade. It's got 2 sockets, 4 cores in each socket, a bunch of DIMM slots. 2 very distinct differences about the blade. One is its stateless blade design, which you mentioned a little bit in earlier segments. It's really an anonymous piece of computing capacity that isn't really enabled until you get a service profile associated with it.
It's an awesome piece of computing policy. I thought I heard an anonymous.
Anonymous. So it's kind of a scratch piece of.
Anonymous.
Yeah, it's anonymous because all the state has been sucked out of it, essentially into the network. So it's just kind of bare capacity waiting for you to associate a service profile and turn it into a real server. That's what gives the dynamicism of being able to provision servers a lot faster. So that's one big difference, and we'll talk a little bit about that more when we talk about the Unified Computing Manager. The second piece that's very different about it is this adapter here on the back. This is a converged network adapter. So it has the capability, what it shows to the operating system is a 2-port 4 gig HBA. This one is actually based on an Emulex chip. We also have another one based on QLogic. And also has a 2-port 10 gig NIC. Both of those are basically muxed onto 2 unified fabric ports on the back. So what the operating system sees is pretty standard. It allows you good compatibility in the system, but it allows us to implement the unified fabric on the back. So you don't have to have multiple mezzanine cards on the actual blades themselves.
These your ports, and then this is the muxer right here. Then.
Yeah, yep. That's the special Menlo ASIC right there.
What? Whose proc is this?
These are based on the Intel Nehalem processors.
Oh, really?
So, yep. So they're each brand new, hot off the press x86 server designs with 4 cores in them. So it's an 8-core blade.
Okay.
And this blade design has 12 DIMM slots in it. I think you'll talk to David a little bit more in the next segment about some special memory expansion technology we have with.
I want to get your reaction out of this too. So, Jameer, what's jumping out at you?
This is the half. This is the half slot one, right?
Yep. Yep.
So you got a half and a full.
Yep.
This is pretty. This is pretty darn interesting. I mean, I like the fact that this is an anonymous piece of hardware. That truly makes it stateless until we actually initiate it. That's pretty sweet.
Yep.
But we got a couple hard drive bays here in front too,
Yep.
right?
Yep.
Okay,
So you
now,
put in two SAS drives there if you want to store the operating system there or use them for swap space.
what's a console port for? Old school management?
Yeah, it's for debug. You can certainly go. For folks who are actually walking around the data center floor who might need to plug into one of the blades, you get KVM access, virtual media, so you can mount a CD-ROM or something to it if you need to.
Very cool. Very cool.
Yep.
All right, let's check out the next piece.
So that thing will slide right into the front of the.
Am I allowed to touch this?
Yeah.
Of the chassis here. We actually got one of the blades already slid in here. So the design is eight of the half-width blades. You can take the dividers out to get to the full-width blade.
Oh, really?
Yep.
Oh,
yep.
that's pretty cool.
Yep.
So if I want to do that, oh, that's cool.
Yep.
So you just pop the tabs and
Yeah.
then I can put the full side. That's pretty cool.
You got the power supplies on the bottom here, and in some respects it looks pretty standard. The big differences turn out when you look at the back of the chassis. This is where a lot of the optimizations around the unified fabric come from. A traditional blade chassis, what you would see in the back is really small fans and a lot of space for networking elements, essentially I/O modules. The chassis was designed straight from the unified fabric. So what it has is two fabric extenders plugged into this one here at the left and in the center. And these implement the unified fabric. So you have, each of them has 4 ports of 10 gig unified fabric.
These are 10 gig apiece?
They're 10 gig apiece. You can just start with one each for redundancy. So you have 20 gig of capacity to the 8 blades, and you could scale up to use all 4 ports on each fabric extender to get you up to 80 gig.
Hey man, you know what? To be honest with you, if you brought this into my data center and showed me, I would say this looks like an oven.
It's certainly got some.
How do I cool this thing off?
It's got some these big things in the back here. It got 8 fans. So the size of the fans.
Goodness sakes, man.
Is optimized to cool the chassis.
Oh, that's
itself.
fans inside of fans.
Yeah,
like
and
a jet engine.
Yeah, it's 2 fans. It actually gives you better performance. You have 2 fans front to back like that.
Very cool.
Yeah, less power consumption. And also the back plane, which you can't see, which is in the middle of the chassis here, because there's only 2 elements.
Yeah, because that doesn't go back that deep.
Yeah, because there's only 2 elements, 2 networking elements, most of the back plane is actually open, so the air can flow through, easy to cool the system. The fan shouldn't have to work that hard to keep the 8 blades cool.
Is that right?
Yep.
You actually did not have to follow a model. I mean, that's one of the fundamental differences here. You did not have to follow a model that said, how much stuff can we cramp into a small place, creating such an incredible oven that actually stresses the data center even further, right? So there's benefits that continue to accrue from that?
Yeah. The unified fabric is, it's a great technology because older blade chassis designs had 2 physical networks essentially. So they had to have 4 or 8 blade switches in the back of them to go out to 2 physically distinct networks.
That's right.
There's a lot of optimizations that come from just using a unified fabric design with the fabric extenders. The other nice thing about the fabric extender is they're essentially unmanaged. You're essentially going to manage all of it in the switch. So there's no individual management the way you would in a traditional blade chassis where you're going to go into the device manager of the individual blade switch and configure the ports that connect to the servers and the ports that connect to the network.
Is that right? You don't groom the ports out actually on that?
No, it's all managed in the UCS manager, in the network essentially. All of the management of the system, the chassis itself. You also notice there's no management modules in the chassis. There's no separate,
I don't see any
separate extra management servers that are needed. It's all done in the network, essentially in the UCS fabric interconnect here.
Hey, you know what? So I'm trying to look, I don't know if I can see that on camera or not, but the depth of this, and then we swing this around to the front, and we're looking at the depth of the blades here and stuff. How much airflow free space do you have in this box? Because in the data center, heat is the enemy, right?
Yeah,
So,
it's hard to cool these systems.
The smaller we get, that's great, but the hotter stuff gets usually when we start micro-miniaturizing.
Yeah, traditional
stuff.
blade chassis, the back plane is kind of a little bit under 30% open. Ours is above 60%. So it's dramatically,
Seriously?
Looks huge holes in it that allow the air to flow freely.
Is that right?
Yep.
Holy smoke,
It's just if you design a chassis from the ground up based on unified fabric, there's a bunch of physical optimizations you can do around it.
Okay, well, that's cool.
This is part of that paradigm shift we're talking about here as well. Now, I noticed we haven't talked about this.
So the fabric extenders will connect up, and really the brain, as we said before, lives here in the fabric interconnect.
Now, so the fabric extenders are, for somebody trying to get their hands around the traditional data center, the fabric extender is equal to what?
The best way to think about it is kind of a remote line card. If you're familiar with like a Catalyst 6500 or Nexus 7000, it has line cards you plug into it, but they're all managed as one large element. The same kind of concept applies here, except they're not physically in one chassis, one physical chassis. Think about taking one of those line cards out and physically putting it into the blade chassis itself. So you can have up to 40 of these blade chassis connected up to the fabric interconnect. That all acts as one big switch, essentially. It's all managed from one spot here in the UCS Manager.
Really?
And you know, these you're not going to configure and manage these as individual switches the way you would have in the past.
You know, then that really kind of gives us some true N+1 redundancy here that we can do. I mean, we talk about that, but realistically, it's kind of really hard to get to that level without spending a ton of cash.
Yeah, so certainly there's a bunch of optimizations in the design that were designed for HA, N+1. You know, the two fabric extenders, the reason you need two of them, each one will connect up to a fabric interconnect. So the loss of any one of the components, the servers themselves will still have full network connectivity to both the LAN and the SAN.
Wow. So 80 gig capacity is what we're looking at here on the back end.
Yep, and there's also some future-proofing in the design to go up to higher levels of capacity. You know, more I/O modules to be slid in the back here, more ports, faster ports. You shouldn't have to replace the chassis to do any of that.
Let me ask you something, because something that jumps out at me is we don't have the benefit of seeing like the cable reduction here, because we're not actually having this cabled. Obviously, there's not too much from a cable perspective here to deal with. I just want to grasp this because I don't have the engineering background that you do, but kind of the before things were versus what we're looking at here. Help me understand kind of, I mean, can you draw that comparison, that contrast picture for me?
The easiest thing would be to imagine instead of two fabric interconnects here in the back or fabric extenders, imagine 6 or 8 blade switches in the back, with, you know, each of them with 6 or 8 cables coming out of the back of it, because it's often 1 gig and things like that. It's really just monstrous amounts of cables coming out of the back, and it makes the fans work a lot harder.
Yeah, it does.
In addition to just the challenges of laying out the cable, the cost, and you know,
what kind of difference does this physically make to the person's life who's managing this? I mean, one of the things I know that we're still going to be talking about more when we get deep into the management is obviously we're blending some worlds here, and I want to make sure that we also understand, and we've spoken to the fact that I think that can cause some fear, because of the uncertainty that we introduced to the situation, because we've changed a few things with this. It's disruptive to a certain extent. We've got server people looking at this going, how does this change my job, and is my job in danger, which is not a popular topic right now. You know, and the networking guys looking at this and going, does that mean the server guy's about to take my job? You know, everybody's looking at it this way. I know you guys have thought through this, and you've got the role-based management, because you're dealing with organizational structure, right? When you talk about those things, how do we operate our business? Who does what? Allowing a business to make those choices and those changes over time. Are there some operational stuff we need to understand while we're looking at the physical hardware that change?
Yeah, a lot of it comes into the UCS Manager, the software itself, in terms of how you manage it. So we still preserve kind of the role specialization. You still need best practices for a network person to define network policies, the server person to define
their knowledge isn't going to waste here, right?
No,
I mean,
no, absolutely.
That's not going away.
What's going to change, though, is that they're all going to be operating on a single management system, as opposed to using a ticketing system or email or Excel or something to communicate amongst different teams. They'll actually be looking at the same GUI. They'll have different parts of the GUI, which will be kind of their home where they'll do their tasks, but allows them visibility to see what the other groups are doing, but you know, kind of preserving the role specialization, but allowing the management to be greatly simplified. Less points of management in an overall system. Less
stuff to patch, less vulnerabilities out there. I mean, you and I are both security backgrounds, and one of the things that I noticed in one of the latest security studies is that if you take 10 companies that were all broken into, 8 of those companies were broken into due to a vulnerability in the software that wasn't patched for over 6 months. And the more management consoles we have, in particular network management itself or element managers, they tend to be very vulnerable because they have so much deep access and high privileged access into gear. So even limiting that really increases your security posture as well.
Yeah, and the policy-based management should really help a lot, because you'll get consistent server deployments with the same set of network policies applied for all the servers.
Oh, that's an excellent call.
And it should really have better consistency, which not only for security, but is good for high availability. You know, there's the new one that's rolled out will look the same as the other one, such that, you know, if you need to do a failover, like an application level clustering failover, the new server is going to look the same. It's going to have good connectivity.
Well, this really addresses a lot of the issues that virtualization had kind of brought out for us here, which was we went from physical server sprawl to reining that in for higher optimization and getting this virtual server sprawl. But you've now given the ability to truly optimize the assets but not lose control of them, which has security implications, whether you want to call it that or not, just because you know where things are and you know that the policies are applied consistently, and you've moved, because of these service policies, we began seeing this with VNLink and such as that technology comes out, because we've now locked stuff down and we said, you know what, let's take some of your famous fat finger errors out of that equation, right, and make sure that things are applied the way the networking person identified. Says, for this set of things, it's all wrapped up. I've made it possible for you. Let's not screw it up now. Right? I like that.
Okay. We need to find out where the brains are in this stuff before we run out of time, because you're talking about no management here and this and that. Where are the brains?
The brain is actually inside the fabric interconnect. So not only does it perform the traditional data plane, it's got a host of this one has 20 fixed ports, all 10 gig. Data center Ethernet on it. You got an expansion module, which gives you either more Ethernet ports or native fiber channel ports that would connect up to your SAN.
Oh, really? Okay.
So in addition to being the normal switch, that's where this is where the UCS manager lives. So it's very different than a traditional switch in that it not only is used to configure the ports here, it manages the chassis, the fabric extender, the blades themselves, the adapters. It's all managed from a special piece of software that's written in and resides in the fabric interconnect.
Really?
Yep.
Well, so what? Okay, we're talking about obviously a very important piece of hardware here. How we keeping this thing alive? What makes it redundant? How are we building some durability into this product? So instead of actually, because a fear of mine is, okay, all right, I can put all my stuff here, all my brains here, but
it better stay up.
You ain't kidding.
So certainly the design was built kind of the same as you saw on the chassis with 2 fabric extenders. Each fabric extender would go up to essentially one of these switches, and the 2 switches essentially form, you can kind of think about it as an application cluster. The management is actually running on both of the switches at the same time, and there's replication between the 2 switches. The failure of any one of these switches, the application would essentially fail over to the other, the UCS manager would fail over to the other fabric interconnect.
Oh, very cool, very cool, very cool. So, and we've got, looks like redundant fans here. Let me flip this around so we can see this in the camera. Here, you might be able to grab it out of there.
This makes me wonder, have we ever had a data center on the desk before?
Oh, that is an excellent call.
It just occurred to me that I don't think we've ever had an opportunity to put a data center on the lab table. Because there's something's got to be missing here.
Excellent call.
Yeah, it's amazing. You could have a huge number of virtual machines in these chassis. The amount of networking capacity, we have a 2U form factor of this fabric interconnect that has a terabit crossbar built into it. So in terms of throughput, just incredible. The one thing that you haven't seen here is the external storage.
Well, yeah, I mean
that makes sense.
You connect this up to your traditional SAN storage because we have native fiber channel ports in it, or obviously it has screaming fast Ethernet connected up to NAS storage and use that as well.
This just messes with my head about how much stuff we've actually got here, and kind of recognizing, don't belittle the fact that, I didn't mean that word, but there's a lot here in a small form factor.
Well, that's a lot. You're right, and that's a lot of computing power to look at this, because I think typically if I was watching this show and I'm a data center person, I would look and I'd say, is that part of the small business communications solution there?
Yeah, well, imagine a large unified computing system which might have 10 or 15 of these chassis all being managed from a single point, essentially.
I can't, man. That's hard to believe that we can take multiple of these chassis and I can unify that management into a couple of these. Really one of these in essence, because that's where all the management.
Server device management, adapter device management, fiber channels connectivity device management, LAN connectivity device management, all done in a single point of management.
Were you going to point something out over here?
Well, I was actually just talking about the. Hey, you know what? Well, hang on a second.
You got something better?
No, because I'm trying to get my heads wrapped on this management. How are you doing that? Because we're not doing this with MIBs, right? I mean,
no, there's special firmware that runs in all of the components, so that run inside the fabric extender, that actually run on the blade itself. We also do some unique things that allow us to boot our own operating system on the blade to do some blade configuration on the blade. So
seriously?
The whole system is designed to work together.
Whew, man, that is heavy. That is heavy duty, but. Let me just real quick point out a couple things here, because it looks like we got, obviously, since it's a data center class product, we got redundant fans, redundant power supplies. Man, really, all the power and the cables come out through the front. Just like a good
front to back cooling
data center 1U. Very sweet, man.
Better performance, smaller device. Thanks very much. As with any new technology, especially one as disruptive as this is, how it works within your system is absolutely crucial. What do you need? What might you already have? That's what we're going to show you in segment 4 coming up. Today we're looking at truly groundbreaking innovation for making the data center more agile and more responsive to today's business. Brian Schwartz and David Lawler are back with us in the same studio at the same time, and you guys are here to explain how well this technology plays with others, right?
Well, yes, they are. With the whole thing about let's get physical, right? We did that in the last segment. I want to see how we actually interoperate with this stuff. Now, understanding, of course, that we're looking at some of this stuff in advance, right? So some of the things we see here from a skin or a GUI perspective, probably subject to change. I think
yeah, it's an early beta build of the software, but the functionality is pretty much the same as what the release product will have.
Well, let's fire it up.
So what you got?
So the first thing you'll notice is that it's a classic embedded device manager. So it comes free with the system, and it does first it does discovery of all the components. So you can see here that I have a pretty simple system with just a simple chassis, one fabric extender, shows you the server itself and the interface card.
You know what, though? But wait a minute, though. Let me kind of interrupt you here because you're showing me this stuff here, and I'm thinking if I'm watching this show, and let's say that I'm a sand guy, and I've got a certain level of insight into my network, this is not really that impressive.
You know, this is a lot different than traditional device managers, because what you had in the past was you would have different device managers for each of these components, and each administrator would log in and manage a different component. So there's never one view where you could see the access layer switches for both the LAN ports here and the SAN ports and all the things about the servers and you know,
so you're saying there never was, in the normal world that we're accustomed to, and the shift we're going through on today's show, you couldn't have seen all this thing. It would have been individual device managers. Yeah. So don't overlook the fact that we're looking at it all together here now for the first time ever.
Yeah, and imagine a system, you know, at full scale, 40 chassis, 80 fabric extenders, 320 blades and adapters, all in a single pane of glass.
Does that answer your question, though?
Yeah, it really does, because that is really the difference here is that by integrating the network, I won't say network layer because that obviously doesn't map too well, but it's the network portion of this that actually makes the difference.
Yeah, the fact that the access layer of networking and the servers themselves essentially been fused together from a management perspective into a single system. It's all one device essentially. So you can see in all these things, you know, it's kind of still the, you know, to the question you asked before, Rob, about, you know, how does this play with the existing specialties? There's kind of, you know, in addition to all the
base management stuff?
Yeah, there's kind of tabs here that you'll see. You know, there's a place for a server admin to do most of their work, a LAN admin to do most of their work, and storage guy to go in.
Hey, that's sweet. That's cool.
Yep. So there's the logical administration.
I don't know if everybody caught that. So what are you talking about?
So these you can see these three big tabs across the top. So you'll still have role specialization. You know, there's a lot of knowledge that gets built up in individual server teams and in the LAN networking team and SAN team. They have a place for them to do their traditional jobs, to go in and do the same types of tasks they've done before. But now they're putting it into a single system as opposed to a bunch of discrete device managers.
That's very cool. That is very cool.
So let me just quickly show you if we wanted to create a service profile. So,
all right, let's first off, what is a service profile?
So a service profile is the way that we essentially implement the stateless computing concept. So you create essentially what you want to be the end state of the server and the access layer connectivity in the actual system. You create it in software, it's essentially stored in software. And the three specialties kind of put in what the configuration should be, and then you can choose to deploy it out to an individual server in the large kind of compute that's connected to the fabric interconnects. And when you deploy it, it configures not only the server but the adapter, the fabric extender, and both the server-facing port and uplink port on the fabric interconnect all in one shot.
Let's see it, man. That's.
So let's go in here and do a quick TechWiseTV server profile here. Service profile. And so one of the things you'd first do is you would create essentially what you want your NIC to look like. So you're going to go and create a NIC, and not only are you going to say I want a NIC, I want it to be on a certain VLAN that's already been defined by, say, one of the network architects has gone in and defined all the VLANs. I'm going to choose this one here, TechWise VLAN.
Oh, thank you.
Love that.
Yep. Going in.
That's the party VLAN.
Going to connect it, and here's you can quickly see some of the policy-based nature of the system. So we're pretty big on policies because the data center is becoming a lot more dynamic, and you want to have some of the experts define a set of policies, and then some other admins, maybe some of the more junior admins.
What's a pin group?
Just go in and select essentially a bunch of drop-down boxes here that a predefined policy, and of course I'm the expert in the back, I've already created a certain pin group, which is which uplink port do you want to be configured to for this service profile. You just go ahead and select that, and again, when you deploy this out, it doesn't matter which chassis, which blade you define, this service profile, the traffic, the LAN traffic for that is always going to come out of that port, that uplink port.
Groovy, man.
Yep. And you basically go through and do the same thing for. Oh, let's not do that. I want to cancel it. And just finished. You basically go through and do the same thing for the HBA. Determine which vSAN you want to be on. You can select which server you want. Pick an individual server, or select on a pool that's based on certain hardware characteristic. Give me one with the memory expansion. Give me one with the fancy virtual interface controller in it. Same thing. Set up all your boot order.
Set the boot order. How cool is that?
Yep. So you can go in and say, you know, do I want to do local boot? Do I want to do SAN boot? Do I want to do Pixie boot? And
awesome.
Again, when you deploy it, it goes in and programs the BIOS directly.
Unreal.
I'm kind of curious, because with your background from a server perspective and stuff, what is it even possible, because I know you've been involved in this deeply in the development, David, but as you pull back and you think in the old world about the way you used to think in the development you were doing at Sun and stuff, what's this kind of stuff mean to you as you look at this? And you're seeing kind of a baby having been birthed here, if you will. Here's a child that's come out. Any thoughts on what this means?
It solves the adolescent problems of the child we have, right? Basically, you know, you got all these different systems, and as Brian's saying, different tools for managing them, different tools for taking care of firmware, different tool for taking care of the adapters, different tool for taking care of identity, all that, and people have to coordinate that. What this does is it actually makes it single, right? It makes it actually working with the infrastructure. It was addressing a problem that we had, that frankly the only way that people have actually been able to look at it, because of the way they've been doing business basically, is additional tools, more tool. I'll give you another tool for that. Wrap it in another tool, right? And so
that's right.
Right? And that's been the answer. So this basically says, okay, you know what? Let's make the device itself as a whole smart, and then give you an interface into it.
You know, that's one of the things. There's so much here, obviously. That's incredible, and I think that as I was learning more about this, the thing that kind of just absolutely blew me away was some of the problems you guys solved with some of the memory mapping, and that's such a big topic, because when it comes to adding, memory in machines, a lot of server folks out there today, they're buying 4-way systems, only putting a couple procs in just so they can get the extra memory boards.
Right.
And so, I mean, we're really talking about a new way here to really cut back in cost, just because of hardware and where we're deploying this stuff. But how'd you guys solve some of these problems with all this massive amount of memory here? I mean, if I saw that on a data sheet, I'd be like, there's marketing at work right there. There's no way they can do this.
So what we looked at, I mean, we looked at the blade basically, and we looked at the capabilities of what we could do with Nehalem, and we talked to customers, and it was first of all, it was identifying the problem, right? Is memory the problem, or what is the problem? It's looking at virtualization. People are running out of compute cycles before they're running out of memory. Vice versa, excuse me. They're running out of memory before they ran out of compute cycles.
Right,
Sorry about that, right? And, so how do we solve that? And you're right, people are looking at 4 sockets. So it was extremely insightful, right? And we work with an absolute gifted engineering team who looked at the problem and saw a simple answer, rock stars. I mean, a simple answer that, and that basically was, in hindsight, looks, well, that's simple. But like anything, you look at the system in Nehalem. This is a Nehalem system. It's got 12 DIMMs, right? And so each one of these DIMMs, and I have no idea what the size of this. Let's say these are 8 gig DIMMs. Each DIMM is a single physical DIMM. That's what the memory controller is looking for. Now in Nehalem, the memory controller is actually on the processor, right? So the memory controller, that's different. That's new to this new architecture. They just announced it, and basically what that does basically is it actually gives a much higher performance, more bandwidth, a whole bunch of pluses to it, right? So it puts them back in the game. On that standpoint. But you look at the memory, and I've got on this kit system 12 DIMMs, right? And that's at full performance, right? So maximum memory bandwidth. Well, we looked at it, and as I said, just absolute ingenious insight into this. Basically was, well, if I've got one DIMM that's 8 gig, can I represent that as 4 DIMMs at 2 gig? Right? It sounds simple, right? And it's a simple, in networking, it's like I'm addressing an 8 gig DIMM. I've got the addressing mechanisms. Let's see if I can do it. And you know what? You can't. So what we're doing basically with that system is you'll take effectively the exact same blade as this from a compute standpoint, same processor, same capability in the disk subsystem, same service processor, right? And then because we want to have more DIMMs, effectively it's double width. So we have up to 48 DIMMs on that system, basically, and they're you can use less expensive DIMMs. So instead of a bunch of 8 gig DIMMs, I can use a bunch of 2 gig DIMMs, right?
Which is a tons amount cheaper in cost.
Yeah. But the other side is that, you asked that question earlier about, just something out of the parts bin, right? This is ASIC level picosecond basis of computing. I mean, just basically picosecond networking effectively on the memory bus, right? So it's ASIC development from the ground up to be able to do this, right? And that's what we've done. I mean, basically doing it, the net basically is that you save just on memory costs alone 50%. right?
Oh, yeah.
Compared to other systems out there. Even, you know, so some people say, well, I don't need 384 gigabytes because that's our maximum. On a 2-socket machine, we can go up to 384 gigabytes of memory.
That is unbelievable.
I know. You know, you look back.
That's
Well, it's previously considered impossible, right?
yeah.
Oh yeah, exactly. I mean, you look back even when 32-bit, 64-bit computing just came out in 2004 time frame. At that time, an x86 box had, if it was lucky, 4 gig. Right?
That was a lot.
Right. That was a lot. that was a lot. That's exactly right. Right. You know, yeah, people figured out that they can use the memory now, and virtualization's eating it up, transaction processing's eating it up, search things are eating it up. Well, what you can do then is say, okay, I can go to larger memory footprints, and people are doing that. Right? And so we've got customers who said, they looked at it, and we talked to them about virtualization, they said, man, I can use this over here, and I'd like to use this over here. And they're looking at new business opportunities, ways of analyzing their data better, right? Other people are going, and normally it would be 96 gig, but this will save me, in that case, about 60% of the cost.
And you should be able to have higher consolidation, more VMs on the same physical box.
And this boils down because of the way software is charged for, right? I mean, you talk about huge cost savings, which contribute very quickly to the ROI when you talk about deploying a system like this in terms of the benefits it can give you. Now, what I'm worried about is that we've got a lot of revolutionary topics to discuss. One of the things I want to make sure we cover just before we leave, kind of drawing in, talking about the architecture while we still got both of you here, benefit of 2020 hindsight now. We've been blown away at the shows that we've done of the various Nexus products, but we were looking at them from a networking only perspective, and we were still very impressed, don't get me wrong. But now all of a sudden you go, you guys were holding out on us, because now we begin to see, well, that's why the ports were in the back. That's why the airflow was done the way it was and such, because there was a bigger purpose in mind. Can you tell me, as briefly as possible, because I know and that may be not a good thing to ask, but tell me how that stuff ties in. How do you normally speak to it so that make sure we don't miss those points?
And that's, when we talk to people about this, I mean, there's so much innovation in this. There's too much at one time. Right? And you look at Unified Fabric, you look at VN-Link, you look at the Fabric Extender technology, just on the networking side alone. Then you look at the memory, you look at the management, you look at the virtualized adapter, right? We talk to people basically, we've made sure we're bringing all these other technologies, as many technologies as we can to market separately. So Unified Fabric's available. Fabric Extender's available as a product. The VN-Link technology is being made available as well, the next generation of VMware. Right? So all those technologies, bring them to market so people can understand them, and then it's not all new. But what we do basically in this whole system, it relies on those technologies, people, and then it scales, right?
Wraps the management around the whole system.
I'm amazed at because I sit there thinking, I'm like, the management's a real unsung hero of this story. I'm like, no, wait a minute, it's the adapter card. No, wait a minute, it's really the memory when it comes to it. No, wait a minute, it's really how the chassis is built, and I got all the airflow in there. And I didn't even know what to even point to. How do you even summarize this?
I wasn't even going to try. I was just going to hand it back over to Valerie.
And he was handling ever so nicely.
Will you summarize it for us, Valerie?
Thanks very much, guys.
You're welcome.
David Lawler and Brian Schwartz.
Thank you.
Glad to have you. And next we welcome Dave Major from Learning at Cisco. Good to see you.
It's very good to see you.
In black on black, the very hip, chic San Francisco uniform.
I had to keep it cool because I'm here on TechWise TV.
We are tragically hip on TechWise TV. What have you got for us today?
So I have a couple brand new things. We're talking about data specialization. So we have 2 brand new specialist certifications that are going to come out. They're data center virtual specialization for design and for support. And those are going to be coming out probably a little bit later in the year. We'll have Marcello Hunter back on sometime a little bit later on to give you a brief update on that.
Okay.
And then we also want to tell you about some brand new courses that are going to be coming out on the Cisco Learning Network store.
Excellent.
We actually have a brand new store that's going to be coming out right around the time that we're here on TV, here on TechWise, and tell you all about that. We have brand new e-learning products that are going to be coming out. I think we talked about the Mindshare game on the last TechWise TV. You can actually purchase that on the CLN store, as well as the brand new CCIE 360 routing and switching product. So those are all available. You can actually go on to the Cisco Learning Network and purchase those.
Oh, good.
So for the first time, you can actually go online and purchase Cisco education products from Cisco.
Excellent. Dave Major.
And I'll give you a quick update, just to tag at www.cisco.com/go/learnnetspace.
Excellent. Thanks so much, Dave.
Thank you.
Okay, Rob, you did a good job of summing up for us. You kept your promises. You hit the discussion points.
That's the big question, though. Did we really? Because the big fear is that when you talk about all the intelligence that's been put into this and the engineering talent that's led up to this, because as we've worked with this team, Oh my gosh! Not only are these guys highly intelligent, they're very busy. They've been leading up to these points today, and we're blessed to get to work with them at the same time. I hope we're doing them justice with regards to how we're covering it on the show. I'm trying to take some notes here because some things were hitting me, and some points that I think we need to remember when we look at this. First and foremost is that if anybody's watching this show today, we've just been through a full hour of content just about. If anybody thinks that this isn't a fundamental change to the way things are done, and they see those points that we've been trying to do a good job of drawing out here, rewind, go back, watch it again because you missed something. Now, I apologize if it was us and the way we explained it.
I
That
was just going to
bad.
say we probably missed something too. There's just so much we could have covered.
But if you think about it, there's this systems orientation, this ability that says, you know what, we're not going to force you to integrate everything on your own anymore. That's what's really jumping out at me. It's saying there's a lot of things that can be done together. This is not about a networking company trying to reach out and act like we know what servers are. We have server people that have proven their abilities in the market. We've brought them in to help solve what were really looked at as being problems you couldn't solve before. No one even thought to potentially address that. That really jumped out at me. But the ability to remove operational complexity, the integration of these things, the memory breakthroughs. I forgot to ask how many patents we probably have on all this stuff, but it's amazing. It's fun to be a part of it. Bottom line, we talked about this at the beginning, it all boils down to this is technology stuff, you know, and when you talk to the business folks, we talk about the reason all of this exists. It's about agility. It's about how can we improve our ability to respond to the changing market conditions, which continue to happen much faster. There's many more dynamics we have to deal with. These are the kind of solutions that allow us to focus on the business at hand so we can add value to the things that are going to make a difference. And I sure hope that everybody got that point clear.
Sure hope so. That's the final word. For Rob Boyd, Ginny Ray Purser, I'm Valerie St. John. Thanks for joining us on TechWise TV. Now, to find out about future episodes or to check out a complete archive of previous shows, be sure to visit the Cisco Interaction Network at cisco.com/go/interact.